Geometric progression. So previously we've had a look at arithmetic series. We've had a look at a few different series and sequences in or using nth term as well. So now we're going to be having a look at what a geometric progression is, being able to work with them, understand them, including their formulae. So first of all, what is a geometric series, geometric progression? So it is a series where the next term is the previous one multiplied by a constant. Now this constant we call the common ratio R, and it's going to be the same throughout the whole series. If R is negative, then the sequence is going to alternate between positive and negative. For example, if we have the first term as 2 and R is -1, then each time we're just multiplying by -1. So it'll be -2, 2, -2, 2, and so on. If R is between 0 and 1, for example, if R is a half, then the terms are going to decrease in magnitude, so get smaller as they go along. So it might be, if we start off with 64, we go down to 32, down to 16, 8, 4, and so on. But equally, we could have a negative number. We could have -64, and then we'd go down to -32, and so on. That's why it says decreasing in magnitude, because the actual size of the number is getting smaller rather than the value. Because you can see here with the negatives, it's getting bigger. Last thing is that the nth term of a geometric progression is a times r to the power of n minus 1. Now, this is an important formula to know, and we need to know what each part is. So a is the first term. Okay, so in our 64 sequence here, a is 64. R, as we've already mentioned, is our common ratio. N is whichever term we want to look at. So say we want to look at the 10th term, n is going to be 10. So thinking a little bit more about those common ratios, let's have a look at this first geometric series. So we've got 1, 2, 4, 8, 16, 32. We should be able to recognize reasonably easily here that each time we're multiplying by 2. The sequence just doubles as it works its way along and carries on forever. So this means that our common ratio is 2. Okay, so that's what we're multiplying by every time. If we do the same thing for the next one, so we want to look at what we have to multiply 27 by to get to 18, what we have to multiply 18 by to get to 12. Now in this case it's a little bit more difficult. It's not an obvious integer or one of our more common fractions. So we've got to think about what we're going to be doing there. So if we have a look at 18 divided by 27, okay, and we'll see why in a second, that gives us 2/3. If we did the same thing, so 12 divided by 18, so this term divided by the one before it, that's going to give us 2/3. If we did 8 divided by 12, that's going to give us 2/3. Okay, and this 2/3 is our common ratio. That's what we're multiplying by each time. So if you struggle to see what the ratio is, you can divide a term by the previous one, and that will give you that ratio. So times 2/3. If you're ever unsure which way round it is, try it and then see what happens. So here, I'm thinking this is times 2/3. So I'm going to start off 27 times by 2/3, and that gives me 18. So I know that I've got it right. And there we go. Right, there are 1, 2, 3, 4, 5 more to go. Pause the video, have a go at them, and then when you're ready for the answers, press play again. Okay, the answers then. So the first one, each time we are halving it. The next one is going from positive to negative, positive to negative. So we've got a ratio of -1. I should say there that the value of the number actually isn't changing, it's staying at 5. We could have -2, where we had 5, -10, 20, -40, and so on, where it would change. This is an alternating sequence because it's oscillating between positive and negative. The next one if we have a look at what's changing every time, there's a few things here. It's an alternating sequence, so it's going to be a negative common ratio. The coefficient of x, or coefficient of x squared, or whatever we've got, is doubling every time. So we've got a -2, and the power of x is increasing, so it's -2x. Question 6, a little bit simpler. We're just multiplying by p every time. And then the last one, we are multiplying by -1/4. Okay. Right, let's go through an example. So here, we've got a geometric progression, 1, 3, 9, and so on. We want to find the 5th term without having to list them all out. This is going to be useful then when we want the 100th term, 200th. We don't want to be listing out and doing all of that work if we can do it a lot simpler. So, 5th term, n is 5. Let's write down everything we know. We've got a geometric progression here. We've got that sequence. So 1, that's the 1st term. So a is 1. And if we have a look at what we're doing every time, we're multiplying by 3. So r is 3. We now have everything we need to use this formula. Okay. So the 5th term, u5, is going to be 1 lot of 3 to the power of 5 minus 1. Okay. 1 times anything is just itself, so that we can sort of ignore that. We've got 3 to the power of 5 minus 1 is 4. 3 to the power of 4. 3 to the power of 4 is going to be 81. So there we go. Without working our way all the way through, we've got there from one small formula. Pause the video, have a go at the practice one, then press play when you're ready to go through it. Okay, so 7th term here, so n is 7. A is our 1st term, which is 3. And each time here, we are multiplying by 4, so r is 4. Substituting into the formula then, u7, so the 7th term, is going to be 3 lots of 4 to the power of 7 minus 1. Or 3 lots of 4 to the power of 6. Now, you're not expected to know 4 to the power of 6 off by heart, so feel free to use a calculator. 3 lots of 4,096, which then, if we multiply by that 3, we've got 12,288. Now, this seems like quite a big number, especially if we've started off with 3, 12. So let's just have a think. We're looking for the 7th term, so quite a few terms, and each time we're multiplying it by 4. So it's going to grow very big, very quickly. Okay. So in this case, that does sound about right. Now, we've looked at finding individual terms. Let's have a look at how we can sum them together, so add them up. So the sum of the first n terms of a geometric series is the sum to n of a multiplied by 1 minus r to the power of n, all divided by 1 minus r. Now, whilst this might be a slightly more difficult formula to learn off by heart, it's still very easy to use. We just substitute in and then simplify. So that's what we're going to do. We've got our sequence here, 1, 3, 9, and so on, and we want the sum of the first 8 terms. So n is 8. A, first term is 1, and if we have a look at our geometric series here, geometric sequence, we're multiplying by 3, so r is 3. So sum to 8, and I'm using the formula in the top right here now. Okay. Sum to 8 is going to be 1 lot of 1 minus 3 to the power of 8, all divided by 1 minus 3. And it's really important that when we're doing this, we just substitute first. Don't start simplifying it yet, because that's when mistakes start coming in. At this point now, then we can start the simplifying. We don't need that one on the outside of the bracket. So we've got 1 minus 3 to the power of 8. So 1 minus 3 to the power of 8 is 6,561. And then we've got 1 minus 3, which is -2. If we then tidy up the numerator, we've got -6,560, and we've got -2. So our final answer then is 3,280. Okay. And to be honest, 8 terms, again, we're expecting it to be in the thousands. We're multiplying by 3 every time, so it's going to be getting quite big quite quickly there. Right, pause the video, have a go at the practice one. Press play when you're ready to go through it. Okay, so n here is 6, a is going to be 3, and r, we're multiplying by 4 each time, r is 4. So the sum of the first 6 terms is equal to 3 lots of 1 minus 4 to the power of 6, all divided by 1 minus 4. Again, if we expand that out, or sorry, simplify it down, tidy it up. So 4 to the power of 6 is going to be 4,096. And on the bottom, we've got -3. So we've got 3 lots of 1 minus 4,096, which is -4,095, all over -3. Now, just to save me a bit of effort of multiplying and then dividing, we can see those 3's cancel, the negatives cancel, so our answer is 4,095. If you wanted at this stage here, you could have just typed it into a calculator, but it's always nice to work it through where you can. Okay, hopefully all of that makes sense. Any problems, let me know.